Hello everyone, I am Dr. Ramesh Bharti, Department of Engineering Technology. Today we are talking about very interesting topic about Aloha and protocols and along with the CSMA and CD. So why we are talking about this topic? Because a very important part when we are talking about there will be of two different channels and we have to send the data. How data will be sent from one end to the second end with the help of these protocols. We will try to study that why these protocols are needed. So if we talk about the importance of this Aloha protocol, first we will talk about these are some of the topics we talk today about what about the introduction, why we need it, channel allocation problem, and the LB of the multiple access protocols. So if we start with the transmission, we will talk about the introduction part. We have a broadcast network, and what about key issue? Key issue is we have two different channels and we have to transmit our data. So how get the channel when there is a competition? Like if we have a different number of users to send and different receivers to send, then how we can transmit our data with the channel? So it will be the part of it. We will say if we want to complete this task, we have two different type of methods: multiple access channel and random access channel. Right? Multiple access, we have a different methods to transmit our data. Random access, it means if the packet is available and each one have to send the packet with the help of channel. So if we talk about this, there will be one problem arises that we will call it a channel allocation problem. Like how we can transmit our data from one channel to another channel. So we can say, if we talk about in this section, we can say the channel allocation, there will be two types of channel allocation. Either we are talking about the static manner or dynamic manner. As the name is specified, static means we will talking about one to one. Dynamic manner, if we have a channel idle, then if the other have a packet to send, then he can send the packet. Otherwise everyone have to wait and they have to send one by one in a static manner. So we will talk about in the two different approaches, static and dynamic manner. If we talk about in this channel allocation problem and the assignment, we will talk about the performance factor, how we can analyze that which will be best for our purpose. So for calculating the performance of the this channel, we will talk about the medium access delay and throughput. What about medium access delay? Medium access delay, the time between a frame is ready and the frame can be transmitted. Means frame is ready and it will be transmitted through the channel and it will be received, it will be accepted by the receiver. Second part is throughput. If you have a number of frames, then n number of frames can be transmitted in unit time interval. What about the time interval? If any frame is destroyed, then we have to send it again. So we will call it if number of frames we have to retransmit it according to the throughput is low. So we will take these two performance measure. Again, if we talk about the channel allocation scheme, we will talk about here there will be two method of FDM. FDM stands for the frequency division multiplexing. In this manner, we will divide our channel in a different n slots, and we will send one by one with the help of this technique. So we can say the bandwidth divided into n equal size portion. We have a n different portion and each one is responsible to send the data from one end to the second end. If we talk about the problem in this area, so we can say if we have a number of senders, if it means we have a number of senders, it means we can say the large number of senders, then again we have to manage the system. It's one of the key issue. Then sender continuously varies. It means we are saying if we are talking about in this manner, sometimes we have a 10 number of senders and again it will decrease 8 and again it will be again the second time it will be 12 or 15. So again we have to manage this type of problem also. Then bursty traffic, we can say if the channel is very noisy, then we have to manage it, how we can transmit our packet successfully from one end to the second end. So these are some of the key issue. If we talk about in the number of user of the part, we can say there will be of the three different type of strategies. We can say if we have a n number of user, that will be maybe in the available frames. If we have a less number of n, it means we have a less number of packets we have to send and number of users are more. And again, if we have a equal number of users and equal number of data packets to send. So these are the some of the way we can say greater than, less than, and equals to. We have a talk about this. So n times was then all frames queued in one big queues. We are sending a data in packet form. So we can say if we are sending in a packet form, so one by one we are sending our packet and it will be make a queue and it will be approaching from one end to the second end. In the second method, if TDM method, if we talk about TDM method, the TDM method is similar to the FDM, but instead of the frequency, bandwidth, we will divide a time slot. So TDM says each user is statically allocated every nth time slot. So we can say every user will be assigned a time slot, and with the help of the time slot he will send a data packet from sender to the destination end. Again, as earlier I talked, the same problem, because the only the difference is the time and the will be of the frequency. So we can say the same problem which arises with the FDM system, the same problem is here. If we talk about this, under what circumstances a static channel allocation scheme efficient? We can say these scheme, how we can analyze the scheme is efficient, and what generally we can say if we have a less number of data packets, or we can say we have a heavy data packets to send, then we can assign one by one. In that part the channel utilization is complete. In that manner we can say this technique is complete. Otherwise, if you have some dynamic manner, number of user will be increasing, decreasing, or data packets is available or not available, in that case we can say these schemes are not very useful. In that manner we will talk about the dynamic channel allocation. In dynamic channel allocation, what we says everyone has to send the big packet in any time when the channel is available. So whenever the channel is available, channel is free, everyone will send a data packets. So if we can say if we have a less number of data packets, in that case no one have to wait our slot, then each one have to, it means we can say if we are saying we have a 5 number of users, number of user 1 2 3 have a no packet data to send. Fourth user is have a packet data, it has to send. So with the dynamic allocation they don't have to wait their number, they have to wait whenever the channel is available, they have to send. It means directly fourth number of user can send the data with the help of dynamic channel allocation. So the key assumptions of this dynamic channel allocation, we can say the VPK sensitization model, it will be of the independently we can send the data packet. Work is generated continuously. It means one by one, whenever a data packet is available, it can be transmitted by using a channel. Again, one program per station. It means we will set one program whenever the channel is free available, the packet data can be sent by the users. A station is blocked once a frame has been generated until the frame has been successfully transmitted. Channel is blocked whenever the whenever the data packet is available in the channel. Whenever the packet data is sent, another user can send the data. If you apply this, there will be of the no problem of the collision. Similarly, we can say there will be a single channel assumption. We can say we have to send the data packet data with the help of a single channel with the multiple user and multiple receivers. Again, the key assumptions, because I have told you that if number of one packet data will be available in the channel, then there may be chance of collision. In that way, the packet data will be destroyed and we have to retransmit it again. So we can say that we will call it a collision. So we have to take care of this collision assumption. So collision, the two frames are transmitted simultaneously, overlapped in the time and resulting signal grad. So this will be the problem. It can be detected by the all stations, it can be detected by all the stations, no other errors. Basically, if we talk about the dynamic channel allocation, it will be one of the biggest issue, the collision. So we have to take care for this. Again, if we talk about the dynamic channel allocation, we can say we can transmit our data in the two different manner. We can say either we will talking about a continuous manner, or we can call it a discontinued manner, or we can call it a slotted manner. If we talk about the continuous manner, in continuation frame transmission can begin at any instant. It means whenever we have a data, it have to be sent by the network. So no master clock needed. We do no need to any calculation or master clock is available, and we have to need any master clock. Whenever data is available, it will be sent by the network. In the second part, when we talk about the slotted is that we can divide our information with the different time frame slots, and we will send the data. So the frame transmission begin at the start of the slot. Number of frames obtained in a slot. If we talk about, we have a no data to send and we have a large data to send, so we can divide it three categories. We can say we have a no data to send, we will call it a no packet is available. There zero packet is available. We have a all packets are available, we will call it a one. Sometime we can say there will be of overhead problem. We have a more than the packet users, the packets are more available, then we will call it a there will be of the greater than one. Again, in this dynamic channel allocation, we will talk about one more issue. We will sense the channel. We will call it a carrier sense. Carrier sense means if we transmit our packets simultaneously, we will transmit packets. So it may be the chance of collision, and if there is a chance of collision, we have to send our packet data again and again. Whenever there will be a collision, we have to send a packet data to via channel again and again. So for avoiding this problem, we will sense our channels. We will sense if the packet is available, no other one then will transmit by using a channel. So a station can check channel before transmission if busy, station idle. If anyone have already sent the data packet, other channel will stop it, and we will it will not transmit the packet. And we will say the similar system we will use in a wireline lane. If we talk about, there will be of no carrier sense. We will say whenever there is packet data, they have to send. So we will say can tell the transmission successfully later. It means we will assume there will be of the successful transmission or not. We will calculate the packet data has been sent or not. We will end of the time we will calculate it. So we will say wireless network and cable modems. We will use this using this technique. Again, if we talk about the main topic, multiple access protocol, we will talk about this topic Aloha. So Aloha is a protocol which manages the transmission of the packet data from one end to another frame in a dynamic channel environment. So with the Aloha technique, we will sense one more, that we will talk about the carrier sense multiple access protocol. And again, with the carrier sense multiple access protocol, we will talk about one more topic, carrier sense multiple access with collision detection. It means we have a method is available. We have to detect the collision and we will manage it appropriately. So what about Aloha? So Aloha is a system in which uncoordinated users are competing for the use of a single shared channel. It means we have a number of users available in the single channel, and they will use a channel with this coordination manner, like they have packet data to send. So we can say there will be two different versions. So two versions are, we will talk about a pure Aloha, and second one will be the slotted Aloha. What about pure Aloha? Pure Aloha says, let's user transmit whenever they have data to send. As earlier we have talked, we have a data packet that have to be sent by the channel. Colliding frames are destroyed. The assumption is if any frame is collide, it will be destroyed and we have to retransmit it again. Sender can always find out that destroyed or not. Sender find out the packet is destroyed or not. We will take with properly feedback. Property of there will be of the broadcasting, or we can call it in the form of acknowledgement. We will say there will be of the length, will be taking it off immediately. Satellites, if we talk about satellite propagation delay, that will be of the some delay around 270 milliseconds. In this technique, we say by listening to the channel, if the frame is destroyed, we have a random amount of time and we will retransmit it again with the use of same. With the help of this diagram, we can understand the method of pure aloha. Here we can say number of users, we can say there will be of A, B, C, D, 5 users are there, and this will be of your data packet which is to be sent from this end to the receiver end. So we can say, as we have talked, whenever a data is available with the send users, they have to send the data. So whenever we have a data to send in A, it has been sent by the A, these two. Again B have sent the data, again C have already sent the data in D, and again E. So in this way we are talking about where are the collision, it means where is the chance of collision. So we can say, if we take the boundaries of this data packet, so we can say there will be some of the chance of the collision, because these two packets are overlapped in the time slots. So we can say there will be the chance of collision. Again these packet is the chance of collision. Again we can say these packet will have again a chance of collision. If we talk about these frames or chance of collision. So we can say in the pure aloha method, it is a good way when we have a less number of data packets to send, but when we have a more number of data to send, then it will be not a very good method. So for this purpose we will use a slotted aloha method. If we talk about the performance measure, we can say in slotted aloha we will say it's a discrete time slots. We will say agreed slot boundaries, as we have earlier seen. If the boundary is matched with some another frame, then it will be collide, and we have to retransmit it back in as per the policy. So we have to take care of the boundaries. Again the synchronization needed. It means if 5 number of users have a packet data to send, so they have to manage as one by one. So at a time one can send the data, and after the time period when the data packet is already available in the data channel in the far end, then the second user can send the data. So again we have to synchronization is here needed. Again we talk about the performance. We can say, if we talk about the performance, we can say which aloha has a shorter medium access delay and which aloha has a higher throughput. So we can take one graph. With the help of this graph, we can say slotted aloha method can be double the throughput of the pure aloha. So it will be measured by this. We can say, here you are saying there will be two different axes. One is y axis, we are calculating the throughput per frame time, and again in the x axis we have a attempts per packet time. So if we talk about this, we have calculate the performance of pure aloha and slotted aloha here. We can say, if we talk about the pure aloha, it will be given by this method. S is g e raised to the power minus g, and again if we talk about the performance measure of slotted aloha, it will be given by s e g e raised to the power minus g. If we are calculating mathematically, we are saying if we talk about these two parameters, we are saying the maximum part of this pure aloha, it will be of at 0.5. Whenever we have a maximum part of slotted aloha, it will be of at the 1. So we can say, if we take these two, it will be just double of it. It means we can say the slotted aloha can double the throughput of pure aloha. So with the help of this method, we can understand the slotted aloha method will be better than the pure aloha method when we have a more number of data packets have to be sent. Again, if we talk about this, it will be of the aloha and pure slotted aloha. If we talk about the carrier sense multiple access, as we have talked, there will be the problem of collision here. So if we talk about the collision problem, we can listen the channel and detect the collision. If we have a collision, we have to retransmit the data packet, so we will stop the transmitting as soon as collision detected. So we will use this LAN type of mechanism, Ethernet. Collision detection can be processed with the two different ways. We can say one process will be of the analog process and second will be of the spatial encoding process. If we talk about CSMA-CD, collision detection, it will be called as the conceptual model. It will be of the three different parts. We will take it a contention, transmission and idle. We will say there will be of different, at a different part we will take decision accordingly. Minimum time detect collision determines time slots. Minimum time detect to the collision determine time slot. If we have a pipe data to send number of times, so again we have a more number of data, we have to retransmit it again and again. So depends on the propagation delay of the time. So the propagation delay stands for the data packets which we have to send from one end to another end. So this is the performance measure. With the help of this model, we can understand we have a number of frames, and again there will be of contention period. We have a number of the collision frame is there, and again we have to retransmit frame, and again if it is of idle, it will be of the channel is here idle, and we have to packet. So this will be the method through which we are sending a data packet with the help of CSMA-CD. Again next, we can, with the help of this algorithm chart, we can understand the method, how we are taking decision when channel is idle or not. So we can say in this part we will talk about channel is ready to send. If we have we will starting our transmission. So we will start our transmission at the very first end. We have no data packets to send. Whenever the data packet is available, we have to send the data. So again we will send the channel. If channel is busy, we will stop it and we will wait accordingly, and we will if we sense the channel is idle, we will transmit the data packet. Again, no collision is detected, we will say the transmission is complete. If the collision is detected or channel is not available, channel is not idle, in that case we have to wait a random amount of time, and accordingly we have to, or we have a detect the collision, we will detect it, and again we will again come to the there will be a one, we will sense again the channel and we will transmit the data packet. So this will be the method we will avoid our collision with the help of CSMA-CD. So this is all about of the channel allocation problem. We have talked about the various methods, specifically Aloha, pure Aloha, slotted Aloha. Again with the help of pure Aloha, slotted Aloha, we have talked the different methods of FDM, WDM, TDM methods, pure Aloha, slotted Aloha. These are some of the methods. Again we can say there will be of the with the different technique, P persistent CSMA, non-persistent and P persistent CSMA. These are the techniques which will be available with the CSMA, because whenever we are data packets to send, we will vary it from 0 to 1. So whenever one persistent CSMA, we can say we are very sure in the one sure attempt we will transmit our data packet, it will be called a one persistent CSMA. Non-persistent CSMA, we can send a data packet with a number of slots, we will call it a non-persistent CSMA. P persistent CSMA with the help of P probability, and P probability we can say with the two sure shot, it will be the data packet will be available. So we can say P persistent CSMA, we have a probability P and it will be vary from 0 to 1. So again we have talked about the CSMA-CD. So again, other than this, these are some of the more methods we will talk about later on. So this is all about the channel allocation problem with the Aloha and the CSMA and CSMA-CD. Thank you.